This might seem like a really hard question. What is the slope at any point of f of x equals x squared? There's the graph, x squared, and we want to work out the slope at some input value x. We want to make a formula for it, okay? So what I want you to imagine is at some point, you're going to look at a tiny change in y over a tiny change in x, right? That's what slope is. It's the rise over run. And that's going to be the slope of a tangent. The question is how we do that. How can we compute that? Because we need those numbers to be infinitely small to get the proper answer. Okay, let's have a look. So, let's say we have a difference in x, and I'm going to call it h. Alright? The resulting change in y will be f of x plus h, so that's just the output when x plus h is the input, right? That's the total distance of y minus f of x, because we just want to look at the difference in y, not the whole thing, just the difference. And we want to think about what happens as that tiny change in x approaches 0, and we call that a limit. Alright? Well, let's see if we can get this right. Obviously we can't divide by 0, so we're going to have to do something. Let's start by using the f of x. We know it's x squared, so we can put that in. And our goal here is going to be to factor out an h so we can cross them out, right? We need to stop having that divide by 0 there. So now let's expand it out. So that's x squared plus 2xh plus h squared minus the x squared all over h. X squareds cross out. So we're left with 2xh plus h squared all over h. Alright? Notice that every term now has an h. That means we can factor it out. So we're going to put the h on the outside. On the inside we'll have 2x plus h. All over h. H is cross out. So now again, let's look at the limit. So that's just a question of what happens as h approaches 0 of our new term, 2x plus h. Right? Well, it's pretty easy now, isn't it? There's going to be 2x. The h is 0, so there you go. So, what we call this is the derivative of a function. The derivative of x squared is 2x. It's a function that tells you the slope at any point of the original function. Alright? So now let's say someone asks you, what's the slope of x squared when x equals 3? Okay? What would you do? Just have a think. Think about what we just did and see if you can work it out. Well, we have a formula now, don't we? It's 2x, so if x equals 3, let's plug that in. And we'll just get 6. So you can see now how easy it is to do that. And that's the power of the derivative. Applications involve, if you have a distance versus time graph, you can get the velocity. And generally, they're just pretty useful. So that's the intro to the derivative.